Hello, Algebra 2 students. We are beginning a new unit today, and we are going to begin with this lesson on basic factoring. Please copy down the title and also the objective. Our objective for this day is the student will learn the basic factoring strategies and procedures. We say basic factoring strategies because there are several strategies, as you will see over the coming days, and this is just kind of a step one. When it comes down to a problem and you're thinking about simplifying it, basic factoring strategies are always going to take precedence. So that's what we're going to begin today. Now, for those of you that are kind of wondering, when we came back from Christmas break, I said we were still talking about quadratics and the parabolas and things like that, but obviously we haven't seen a whole lot of that yet. Fear not, it is coming. We needed to be able to work with polynomials so that we can work with factoring procedures, and we need to be able to work with factoring procedures in order to be able to work with the quadratics that we're going to have to do here in the coming couple of weeks. So bear with me. We're going to spend a few days on how to factor, and then we will be back to the quadratics. Okay, so let's get started. Okay, just a little bit of background here. Okay, the Latin word for maker is called factor. Okay, it's kind of a strange interpretation, but if you think about it, it actually makes perfect sense. We've talked about plenty of things over the years in mathematics where we've said factor this, factor that, or what are the factors of something. Well, let's take a look. Okay, if you look at a value like 6, obviously 6 is not a difficult value to deal with, and I've asked you what are the factors of 6. Well, the meaning for the Latin word factor is maker. So what are the makers of 6? What are the values that actually build this thing? Okay, and we should know by now that if we break things down far enough, we eventually arrive at prime numbers. The prime numbers are the makers or the factors of everything else in mathematics. Okay, so easy to say, the factors of 6 are 2 and 3. Okay, so 3 and 2 are the factors of 6. In other words, as we said, they are the makers of 6. Okay, this is what we're going to be doing, the idea that we're going to be implementing while we search for the factors of things. Okay, so from that aspect, factors are the things that make something else when they are multiplied together. Okay, so 6 is what we actually call a composite number. It has been built or made by prime numbers. Okay, so last background statement here before we get started. If factors are what build an expression, then factoring is the discovery of those factors. Okay, so that's going to be our goal. When we're instructed to factor something, the instruction is to discover the factors, discover the makers, discover the builders of that thing. Okay, now let's get started on the actual procedure here. The key to basic factoring is simply looking for things that are in common. Okay, this is going to be a very easy idea. We will get into more complicated things here in the coming days. Okay, but this is the first step, looking for things that are in common. Before we start thinking about any crazy math about this binomial or the trinomials that we'll be seeing in the coming days, our first step is simply going to be to ask ourselves, hey, you got a binomial right there. There's two terms. Do those terms share anything? Do these terms have anything in common? Okay, if they do, we want to be able to get it out of those terms before we begin any other more advanced skills that we come to. Okay, so look at 6x squared and look at 8x. Okay, typically what I do is I start off with the coefficients. Do the coefficients have any factors in common? And the answer is very easily yes, they do. 6 and 8 are both multiples of 2, which means that they have a factor of 2. They have been built by 2 times some other value. Okay, so that means we can remove a 2 out of each of those terms. Okay, and then I move on to the first variable that I come to. In this case, it's an x. Okay, do they have any x values in common? Well, the first term has two x's, x times x for the x squared, and the second term only has one x, but it does not change the fact that, yeah, they both have one x that they can let go of. So we are going to take both a 2 and an x out of each of these terms. Okay. Now, after we do that, once we take the 2 and the x away from each of them, we simply have to decide what is left over from each of these terms now that the 2 is gone and now that an x is gone. We'll look at the first term. Okay, it was 6x squared. 2 has been removed from it. X has been removed from it. Well, if the 2 has been removed from the 6, well, what was the other factor of the 6? 2 times what? Obviously, 2 times 3. There will be a 3 left over in that first term. There was x squared in the term. We just took x away from it. So how many x's would be left? There would be 1x. So the first term of our binomial is going to be 3x. How about the 8x up there? If the factor 2 has been taken away from the x, what's left over? There should be 4 left over because 2 times 4 is 8. And it had an x, but the x has been factored out, so our second term will no longer have an x attached to it. Okay, so when it's factored properly, we get 2x out of each of the terms, and in parentheses now, we have the original binomial without those factors, 3x plus 4. And you can also always recheck these answers by distributing the 2x back into that binomial, and you see if you get the original problem back. Okay, so if you're asking why the parentheses are there, why did we create a multiplication or a distribution situation? Because factoring is basically a division operation. Okay, so if we are factoring, we are dividing. If we would like to unfactor, we would have to multiply to undo it. That's how come the parentheses are there, to make that multiplication show up. Okay. Now, obviously, factoring can get more complicated. You can get more terms going on, but it does not change anything that we just said. Okay, so here we have 4x squared times p squared times k minus 6k squared p to the fourth x. Okay, same procedure. Look at the things. This is the first thing you do with factoring every single time. Do the terms have anything in common? Is there anything I can get away from the terms right now? Well, again, it's a binomial, more complicated binomial, but still just a binomial. Okay, start off with the coefficients. 4 and 6. Do they have a factor in common? Absolutely they do. They're going to have a 2. They can both give up a 2. Okay, now just start looking at the variables. First variable I see is an x. Okay, they're going to have any x's they can give up? Yes, both of them have an x they can give up. Also see some p's in there. They have any p's they can give up? Looks like they both have 2 of them that they can get rid of. See some k's in there as well. Okay, how many k's do each of them have? Well, we only have 1 in the first term. The other one has 2, but can't take 2 out of the first term, so we can only give up 1. Okay, so in alphabetical order, which is typically the way our terms are supposed to be written, is we can get a 2 out, we can get a k out, we can get p squared out of both of them, and we can get x to the first out of both. Then you ask yourself the same question, what is left over? In the first term, we took a 2 away, so there is still a 2. We got one of the x's, so there will be 1x. We got both of the p's, so the p's will be gone. And we got the k, so the first term should just be 2x. The second term, don't lose that minus sign. It's part of the problem, so it's going to be subtract. We got a factor of 2 out of the 6. That's going to leave a 3. We got one of the k's. That'll leave a k. We got 2 of the p's, so there'll be 2 of those left. And we got the x, so it will be gone. Okay, so factored, we did get the 2k p squared x, and we left 2x from the first term, and minus 3k p squared from the second term. Looks a little complicated. There's just a bunch of stuff swimming around inside of there. Okay, but it's not a difficult concept. And just the only thing to really keep in mind on this is if you're going to factor anything out of your terms, you have to be able to get it out of all of the terms in order to factor it. Okay, so far what we've seen is that we were able to get values out of the coefficients, out of each of the variables, but it definitely does not have to work that way. Take a look at this one. Here we have a trinomial, 4x squared y minus 2xy plus 10x y squared. Okay, so let's take a peek and see what we can get. Okay, now more terms just means more places to look. Okay, and remember, the maximum amount that you can get from any term is the maximum that the term that has the smallest amount of those things have to give up. Okay, so let's take a look at the coefficients. 4, 2, 10. Okay, now obviously, like over there on the right, 10, 2 times 5. Sure would be nice to get a 5 out of that, because that would really reduce that 10. The problem is the other two terms don't have a 5 to give up. Okay, so we're looking for the greatest common factor. What is the greatest common thing to all three of those numbers that we can get out of there? 4, 2, 10. Obviously, they're all even numbers, so we can get at least a 2 out of all of them. But that center term is only a 2. We can't get anything more out of that term, so there's no other way to reduce the rest of them. So we're going to be able to factor a 2 out. How about x's? Just going alphabetically. The first term has x squared to give up, okay, but the other terms don't have that many, so we can't get 2 of the x's out of the first term because we can't get 2 of the x's out of the other two terms. In fact, the other two terms only have 1 x, so we can factor a single x out of all three. Okay, how about y's? Once again, you can see that the last term has 2 y's to give up, but the other only two terms only have 1 y. So we would factor out a 2 and an x and a y, and then simply look at what is left. So first term, if we take out a factor of 2 and an x and a y, what's going to be left over? Looks like we're going to have a 2 and an x. Middle term, if we take out a 2 and an x and a y, what's going to be left over? Well, it looks like we got all of the terms out of that one. So we're probably going to have to decide, does that mean that the term should go away, or does anything have to be left in its spot? Okay, we'll get to that here in just a second. And the right-hand term, 10x y squared. If we take a 2 and an x and a y, that would leave us a 5 and another y. Now back to this middle term. If we factor the 2 and the x and the y out, does anything have to exist in its place, or will we only have a binomial left over? Okay, well, it's an important thing important question to ask, and the answer is you have to leave a value of 1 in that term's place, because remember, we are basically performing a division operation. If we were to multiply this guy back, basically distribute like this, we would get the original problem back. But if you think for a moment and say, hey, if I had just taken that term away and just left this a binomial, when I did this distribution, would I ever get that middle term back like the original problem had? We would not. We would end up with just 2 terms. And by the same aspect, could you just make this guy a 0 instead of a 1? Well, when you do the distribution, multiplying times 0, you are going to miss that middle term. Anything times 0 is going to cancel. So you can't make it a 0. You can't leave it blank. So what we do is if the entire term is factored, we put a 1 in that place to make sure that the problem is still correct. Okay. All right, the last thing for you is I have 3 problems here. One of them in particular looks awfully bad. Okay, but remember, it's the same principle over and over again. I want you to copy these problems down. I want you to work these and bring them with you to class on the day that these notes are due. Okay, so I'm going to leave this screen up, but the audio is basically finished, so you are done with your notes once you have finished copying and solving these problems. I appreciate you finding time to do your notes, and I will see you in class.